Welcome to the Industrial Talk Podcast with Scott McKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, welcome to the Industrial Talk Podcast. Absolute honor that you are joining the number one industrial-related podcast in the universe that solely celebrates you. The industrial professionals, the companies that get it done. You are bold, you are brave, you dare greatly, you innovate, and boy, do you innovate. You're changing the world and you're changing people's lives. Wow, we celebrate you, and you are absolutely wonderful. That's what it's all about here. And we're going to be talking with another gentleman because the Industrial Talk Podcast features the best of the best, the brightest, everybody that you can think of within industry. And this guy is no doggone slouch. His name is David Hartell. Remember, Hartell. New African Global Energy is the company. He is the EVP. And you know what we're going to be talking about? Digital twin. You might have heard of it. It's a big deal now. COVID, everything. Digital twin. Let's get going. Let's get a crackin'. Yeah, absolutely. So fortunately for me, I have a great relationship with those wonderful people at the Industrial Internet Consortium, and they are leading the way with Digital Twin and working with incredible companies such as David's company to be able to come up with really the framework and the strategies and everything that's going forward with Digital Twin. And it's an exciting time, definitely now in the COVID world that we live in, and recognize that if you were if you were a company that had a digital twin of your operations, it would have been a different sort of transition. And not to say that it wouldn't be challenging, but you'd have greater insights into what's going on with your business. Now, before we get into the interview, I want to reiterate, because over the past, few months in this whole COVID world, we have discussed a couple of things that I want to make sure that you take note of. One, and this is across the board with all of the executives, all the leaders that I've had the fortunate and honor to be able to interview and interact with. One, we need to manage our risks, right? No doubt about it. You can't argue about it. You got to look at your business. You got to look at the risks. You got to manage them. You got to do it now, right? There's a sense of urgency to do that. Manage your risk. And that's what these individuals have been telling me. The other one is to be able to save money. What do we do? What are the strategies that we can deploy to save money? Because we need to save money. We need to really make our operations efficient and save money. And then the last point, number three is how do we make money, right? Manage risk, save money, make money. Pretty simple, right? Now, you're saying to yourself, okay, what do I do? Now, this is the other conversation I had. I've had the same conversation. There are 4 to 5 tenets on the strategies of what you need to do. One, you need to collaborate. You need to sort of put your pride aside, and you need to collaborate. You need to show the sense of willingness to be able to have that conversation. So when we start to talk about collaborate, if you collaborate, both internally and externally, you can ask and have conversations about managing risk and what other companies are doing. It's important. And it's important because you get the latest and greatest thinking. How to save money. Same thing. Through collaboration, through internal and external collaboration, what are strategies that you can deploy today to save money and to create that sense of resiliency going forward? 3, make money. You can collaborate internally and externally on strategies on how to make more money, because we need you. We need you in a big way. You are so critical to this particular economy around the world, not just, in your little area, which it is, but globally, we need you. Okay, you need to innovate. Collaborate, innovate now. Innovate when you want to try to manage your risk. Innovate when you want to save money. Innovate when you want to make money. And that goes across all parts of your business. No argument there. You know that. You need to educate. You need to educate when it comes to managing your risk. You need to educate when it is to save money. You need to educate when you want to make more money. You have got to be able to be innovative and educate going forward. And if it falls outside of those three tenets, the risk, saving money and making money, then if it's an activity that doesn't address those 3 points, you don't do with it. You don't deal with it because you've got to have a sense of urgency. Number 4, you've got to do it with a sense of urgency and speed. And then you're going to say to yourself, Scott, that's tough. I don't want to do that. However, because I'm going to make mistakes. You got to be willing to make mistakes. All right? You just have to. Now, I've got a video out on that, and we're going to be talking a little bit more about it, but those are the tenets. Those are the themes that I have been talking to with many of the industrial leaders around the world. Now, on to the interview. David Hartell is the individual. His last name is Hartell. His stat card's pretty impressive out there on LinkedIn. He's the EVP, Development, Operations, and Production. That's a basket full of stuff. New Age African Global Energy is the company, and he's out of the UK, but that's, neither here nor there. But we were talking about, digital twin. What is important with digital twin? And especially now in this whole COVID world, digital twin. You've got to figure that out. You've got to reach out to this gentleman. You got to reach out with other, leaders within the Industrial Internet Consortium and find out more, because you got to start educating. That's going to save you money. That's going to make your operations more efficient. That's going to create greater uptime. It's all a part of it. Digital twin. That's what's on the interview for the Industrial Talk. David Hartell is the gentleman. Enjoy the conversation. David Hartell, welcome to the Industrial Talk podcast. So glad that you are here. And you're talking from the UK, aren't you?
Yep, across the Atlantic.
The only thing that I have some friends in the UK, and they've got a great accent, and I love listening to them, but you don't have one.
No, I started a long time ago in Texas, and the oil business drug me all over the world, and this is where I've ended up.
So that's interesting. And now the energy industry as a whole has been getting. I don't have the intellectual chops, the skills to be able to even deal with that, but we're not going to go down that road. We're going to go down the road of digital twins. Is that acceptable?
That'd be great.
Because
I'd
I'd like
talk
that.
about it.
Because I have no clue why that is important. Why don't you tell the listeners what is digital twin, outside of the fact that I don't want to see a twin of me, but the digital twin and why that is important. What is it?
Yeah, no, cool. Actually, there's a good definition of digital twin provided by DNV. They say a digital twin is a virtual representation of an asset used from the early design through building and operation, maintained and easily accessible throughout its life cycle. So
did you just rattle that definition off? Did you just do that? I mean, you didn't look at that. I mean, that sounded like Webster's dictionary right off the bat. I'm watching you on video, and I'm going, the hell, that just came right out of his head.
Well, I've talked about digital twins a lot to different audiences. It's a bit of a fancy term. I suppose listeners that might come from building industry have something called BIM, building information modeling and stuff. Yeah. It's very similar to that, where you've got all sorts of data from the very start of engineering all the way out through to operations. So digital twin, I don't know exactly where the definition started, those particular words, but it's a popular phrase right now. But it also can be a little bit complicated because there's different types of digital twins. So you could talk to 10 guys and they describe it, something that might be a little bit different. So it can go from things that have physical data about an asset, something that has process simulation, something about structural. There's all sorts of representations of digital twins, and they're across all industries. So this isn't just energy industry or process industries and stuff. There's things. There's digital twins of human bodies.
I hope there's not one of me. Just FYI. But why is that? Why is this so important? I don't get it.
Well, we have very powerful computing tools now But one of the important things, a computer tool is only as good as the information you put in and then how you use what comes out of it. So they're very sophisticated simulations which can be used, that sort of normal tools that engineers use to design things. You can start building those and put in like a process simulation and then add control systems and then use that when you're specifying and buying instrumentation, and then when you train operators, and then eventually when you operate an asset. So it's something that very much exists across the whole life cycle of an asset. So it's a powerful tool.
Why is it just because we've all of a sudden have the computing capability to be able to do this? I know that it's been around for a little while. We've been talking about it. We might have a representation, a virtual representation of an asset, but it just seems like it's just sort of really a big deal now. Is it just because of
we have orders of magnitude increase in capability of our computational resources, and even things like putting together 3D CAD models of a facility or a laser scan point cloud model. These things, they didn't exist, or it was very difficult or expensive 10 or 15 years ago. Yeah. Now they're just sort of routine, easy to put together, and you can have a model which then you start putting in hyperlinks to contextual data associated with various parts of that model. And so this is just probably accelerated really rapidly over the last few years, where it's a much more commonly available tool that's cheap, doesn't cost a lot of money. It's using design tools that you keep alive through the life cycle.
We talked about getting up front with the design of a particular facility and being able to, put that technology in action at the beginning throughout the life cycle of the asset. What about some existing asset? Can I come back and sort of go, okay, now that we've got this capability, I could go back into it?
Yeah, you can. In fact, what I would be recommending to people now, with the low price of oil and the disruption we've had to the energy markets, now is a good time to try to extract more value out of your existing assets. You don't need to take any finance. You don't, they're there. Let's get more value. If you don't have a 3D model of a facility, you can do a laser scan model and generate a 3D CAD model from that, and you can put in your contextual data. And then you're trying to empower your operators to operate things better inside integrity operating windows. You're trying to get maintenance guys more prepared. So it's getting more information at the fingertips of the operators and the maintenance guys to run your plant smoother, to do things right the first time, to tweak your operations, basically to extract more value with very minimal additional cost.
So I think, and what I hear you saying, I'm sure this is just one element of it, I can sit there and run a scenario on an operation from beginning to end, whatever it is, and run that scenario with tweaks on particular assets to optimize the output or optimize the value of that asset before I even go into the physical component and be able to do the same thing. But I can run scenarios that say, yeah, that's where we need to go, and then come over to the physical and boom, do it. Is that what we're saying?
That's what we're saying. Like in the olden days, engineers would be off and the ops guys would sort of keep them away from things, and they would design something theoretically, and that might work in operations, but an operator could sit down and be running something and find that he's getting pressure surges, or things were closing too quick or too slowly, that the real physical asset wasn't performing as it theoretically was designed. Well, a digital twin model will have all that built in, and the guy can tweak it. So if you see, look, I'm having trouble restarting my compressors after a shutdown, you can tweak and say, well, here's your problem. You've got a control valve here that's too quickly reacting, and you got to put a lag on it. And so you can tweak the controls, how you want to operate something, and then you're increasing the probability then that the guy the operator in the field, when he then implements that, it's going to be right the first time. And we have good evidence of that, where people are going out and starting up facilities. Maybe in the olden days, it might have taken a month to 2 months to debug a control system. Now you're getting up and running in a matter of days.
Really?
Yeah.
Because I live in the old world, and whenever we started to commission plants, it was not a fun time. And so that whole commissioning just apparently takes forever, and a lot of people lost a lot of hair as a result of those commissioning. So
people didn't properly test their systems in the design phase because they didn't have a tool, so they didn't necessarily consider all the different scenarios, and so the control systems weren't set up for that. And then the operators themselves were kind of dependent on the capability of the individual operator. Could he react well to a particular production scenario? Now we have the ability to have all that up front, where we have real good training for operators across a range of scenarios that's more likely what they're going to then experience in the field, and you can test stuff and you'll actually learn from that. So for new facilities, people will be changing the design of control systems. They'll be tweaking things because out of the training and out of the construction kind of phase, you're going to learn a lot, so that then the operation phase is that much smoother.
How do you keep the digital twin looking and feeling current with the asset, the real asset that's operating each and every day? Case in point, I got a pump. The pump's pumping and pump. And just by virtue, there's wear and tear, and the effective or the efficiency of that pump begins to degrade. How does your digital twin reflect that to wear and tear?
Well, that's a great example. And one of the things that we do is when we have the physical data coming in from a facility, we're always in real time able to compare that to the theoretical digital twin. So if there starts being a separation where we're starting to, the physical IoT data is then slightly different from the theoretical, we're able to the engineers can look at that and say, okay, first, maybe that's revealing a problem with our model, but more likely, as you say, there could be some degradation in performance of a piece of equipment or a valve or something, and then you want to tweak that. So you'll be watching those very carefully, because these are also predictive of as things degrade. You want to know ahead of time when they might break, or if we need to change how we're operating them. That's a powerful additional aspect of using digital twin, is staying in front of problems. So you're not being just reactive. Right. You're able to watch as things evolve in the real world.
And theoretically, and you're the expert, I can have an analytical layer between my digital twin and my physical asset, and in that analytical layer of data, I can create parameters, right? If I'm in line with my design parameters, everything's good. But if I start to analyze the data and I'm going in and out of that, then there's a notification. Does that exist? That sort of
no, it does. In fact, not all simulations are pure physics-based output.
Yeah.
So, for example, if you're developing an oil field and you have a subsurface reservoir tied into wellheads at the facility that's then tied into a process plant, that subsurface reservoir, you're going to have some physics-based models, but that's not exactly how a reservoir operates. Well, the same thing can happen even in a facility.
Yeah.
Things can be a little bit different from a pure analytical way. And so you want to tune your model right in the very beginning of life, or when you're trying to start out. You're tuning your model, so you may have some factors you apply to various equations or parts in your digital twin where you tune it so that they're matching each other. This is before you have any degradation of equipment.
Yeah.
You've got to tune it, and so then you're happy. Yeah, we're exactly modeling that.
Yeah, that's pretty trick, man. And when you say it's not that expensive, it's, as a person that's listening to you chirp this stuff out, which is pretty doggone cool, all I could see is that it could be a massive, it could be big. Or can you incrementally sort of approach digital twinning, like incrementally build this out because that's an important component of my process train, whatever it might be, and then so on and so forth. How would I approach that? Because I see the value. How would I approach it?
If you started early, and that's one of my takeaway points is, start early. You got a lot of data that you want to gather. If you're doing it incrementally as you go along from the very beginning, you won't notice the cost. You're keeping track of stuff that you wanted anyways. There's an interesting quote from some people that information, lack of information, can tremendously affect projects. So the idea that you start being organized in the beginning, gathering all this data, then that's not really costing anything. In fact, it's probably going to save you money because you've organized it and contextualized all the data. You're running engineering simulations, whether it's whatever kind of process plant it is, or a factory, or even if it's like a wind turbine, you're running simulations to design things. You keep those live, and you keep tuning those to add additional data.
Yeah.
And so then it doesn't really cost you anything. So the incremental cost to keep it live, probably most firms wouldn't even notice it.
Yeah, and how do you deal with people who pencil whip data, right? But you're going to have to put out, devices out there that that's a 5, and the device says it's a 5, and I'm not relying on somebody that's tired at the end of the day to put in 5, and they don't care. How do you prevent the degradation of quality data?
Well, in fact, when I mentioned about accumulating data over the course of a project, actually, when we get something from a vendor or supplier and everything, he's going to do a lot of testing in his factory. What he has hydraulic pressure to open and close something, how long it takes,
yes,
how a piece of equipment behaves. You get a little signature of that equipment. You want to grab that and keep using that. So you're not like valves. Doesn't matter if it's 2 valves that are supposed to be theoretically exactly the same. They'll have subtly different signatures of how they can operate, and you want to capture those and use those in the real thing, not just a theoretical value, because you won't be properly modeling the thing.
Yeah, no, you can't do that. That's spot on. And I would imagine you could in an existing operation, and you're saying, hey, I'm all in on this digital twin, and we're going to go down this road, and we're just going to do this. The same thing has to apply with legacy assets. Like that pump's been running for 10 years. Let's get some data on that and be able to tune it to my digital twin as is right now. And then
definitely. Engineers can work. Well, first of all, engineers need to be closely linked with your operational guys and your maintenance guys, and neither one of them in isolation. And you can capture the data that you'll know. If it's an existing asset, you'll know, okay, what's been the mean time between failure for these types of things? When did you last service this? When was it last replaced? How have these things been behaving? And from them, you'll capture a lot of data that you want to then put into the model. And you want a result. The end result will be a model where you run it, and the theoretical IoT instruments, the virtual instrument data that comes out of your digital twin, will be aligned with the physical IoT instrument readings that the operators are seeing in the plant. You feel like, okay, now I've got a good model representing this, and then I have the performance curves inside this model for each of the piece of equipment, whether it's a pump or a valve or a heat exchanger.
Yeah. Now, not all IoT devices are the same. You're going to have to go down that road and evaluate the proper device for the asset to begin pulling that data. Is that correct?
Yeah. One of the things that was fascinating to me is there's 2 types of data that will come. There's structured data and unstructured data. So an IoT device could be, okay, just giving me a pressure reading on a pipe somewhere. Yeah, great. But you also have other kinds of things. You have cameras. You have weather kind of data. If you're on a floating facility out in the ocean, you have the motion data. All this other kind of data, you want to capture that and put it into a contextual format where it's then becomes structured. So for a piece of equipment, lots of other data, don't just give me the pressure and temperature or flow rate of something. Tell me other things that are going on to that piece of equipment is experiencing, because that's going to be how I help predict how it's performing, and is it degrading, and do I need to get ready to replace it, or do I need to change how I'm operating it because I'm running it too close to the edge of its of a safe operating window, and I'm wearing the thing out.
Yeah. And see, that brings up the point of saying, okay, I got this asset. This asset is generating specific data, not just pressure, but let's say vibration and heat and whatever, all the cameras and everything associated with that asset. And you're going to pull all that data together to give a really serious and clear picture of the health of that particular asset, real time, which then you can use. Explain a little bit about edge computing.
Well, edge computing, again, when we were talking earlier about how things have changed, 10 years ago or something, you had to get all your raw data from your equipment and had to go somewhere and be processed. Well, now that we have big complex facilities with lots of data coming, we don't necessarily have the bandwidth to transfer all that information through. It'll clog up. It's like clogging up all your freeways. We want edge is like park and ride. We want everybody to get some data together, and then we'll process it a little bit closer to the equipment or the system, and then a simpler stream of information will go out.
That's the van analogy. All the good data jumps into the van and then goes to the location B.
Yeah, even in fact, let's say I'm running a pump and I check every minute, is everything within the specified parameters? Yes. Well, shouldn't need to send 10 parameters. I should send a 0 or a 1, a binary thing. Yes, we're fine. Nothing's unusual. As things start drifting, though, from degrading or something, then we want to have increased fidelity. We want more data more often so we can exactly watch what's happening to it. And so we want to process some of that data on the edge to save ourselves. And actually some of this edge processing can then be used for autonomous control actions. So if we say that if a pump starts cavitating, we want to do some edge processing and we want to throttle that or turn it down or affect one of the operating parameters right there as a way of protecting the pump, edge computing can help us do that.
See, and that's key, because that was always a challenge for me, is that, hey, I could collect data all day long, but it's just, my bandwidth to be able to consume it just becomes just obliterated because it's just data. I have no analytics that are behind it to say, that's good data. That's just noise data, whatever it might be, but this is good data and I need to look at that. And that's what's so interesting about what you're doing. And now you can take that information, the meaningful data, process it, connect it with your digital twin at the same time, right? And now you get a really real-time picture of your asset from beginning to end, whatever it might be.
Yeah, we don't want data for data's sake, and unfortunately that's what's happened in the past, is people had good intentions, but they collected probably too much data, and then McKinsey likes to throw around a statistic and say that 99% of data isn't used for anything. It just blows by us through our control systems. They're probably right, just because it was just too much. And I've had people in conferences say, oh, there's too much data. I say, well, yeah, there's too much probably because you're not focusing on what's important data. And so what's important data? Important data is something that's going to help me get some more value. So I want to start at the end of the process and say, I want more value. What decision did I have to make to get that more value? To make a decision, what insight did I need? To get that insight, what analytics did I need to have run? And to run those analytics, what data did I need? So you work backwards from the value to the data. Figure out what data, what you want to do, what you want to do on the edge, what you have a little bit more time, and you can kick that data up through your communication systems to a cloud data platform and run offline more detailed analytics there, machine learning, AI. You can do fancier stuff and then feed that back. But some stuff you want to do on the spot on the remote facility.
Yeah. See, what you're talking about is really a pretty interesting, just a complete model. So one of the things that has always been challenging is everybody talking about, I got to get more into reliability and manage my maintenance and do more analysis on the assets and all of the stuff that's been, but a lot of these reliability programs have been somewhat, they have various degrees of success. And the reason is it's not sustainable sometimes. But now that you've got a real complete picture, a complete picture between your digital twin and the strategies behind digital twin and your reliability and working in concert, I mean, this is really the time to be able to do it and to create real value, bottom line efficiencies.
Yeah. So all this data, that builds up to my digital twin, I'm using all these kind of things. It's all eventually tying into my enterprise asset management systems. And inside them is the asset performance management. And inside that is maintenance management and reliability, integrity kind of management programs. It's all linked. But if humans were responsible for manually putting data in, or you're wasting a lot of time, this is better to link the thing all together. Then put the data in once, make sure it's the right data. Somebody along the way didn't get a different data and put it in, and it properly went through to your system. And so all the groups are talking to each other.
Yeah. That's a powerful solution. I love it. I really do. I'm fortunate enough to be able to interview a lot of people, and I see the technology that's being deployed today. And when I was coming up as an old pup, some of these things we talked about briefly. We didn't really understand it, but now it's like real. You can do this today. And I think just the virus has sort of sped that decision-making process up. And when you say, hey, you can do a digital twin and it can be pretty inexpensive, I don't see why you wouldn't do it.
Yeah. No, I think we're only limited by our imaginations.
I agree.
So in a world with disrupted energy markets, in a world with public health issues and everything, remote working, reduced manning, things like that are really getting a lot of focus from people. Unfortunately, people are looking around and saying, hey, there is tools here. And so how can I have a remote group of people where they're safe? They're not having to fly back and forth to some remote site. They're safe. They can actually go home at night. They're getting data from a remote facility. Well, what's the best kind of data? Is the data that I've all organized. It's into a digital twin. I'm able to use that. In fact, through things called through virtual reality, a guy can do a virtual round. A guy can put on a headset and virtually walk around the 3D CAD model of his remote facility. And as he's looking at different pieces of equipment, the digital twin is highlighting to him this piece of, he's green. Well, why is he green? Well, that's because he's operating within his integrity operating windows. Or, hey, this guy's orange over here because he's starting to get bounced up against the boundaries of it. So something's going on there. He's running a little bit rough. We need to change how we're operating, or he's starting to degrade.
Yeah.
And so we have the technology for a guy on the other side of the world to be inspecting through a plant, doing a virtual walk around, using the power of the feedback from the digital twin, which can be linked into advanced analytics, and tell him about what's going on. And then maybe you don't have anybody on the site, but if you have just like smaller teams concentrating on maintenance, you're able to work with those guys and support them and say, here, this is what you need to go focus on.
And here's the screwdriver that you need, and here's the replacement part that you need. Bring it all out there at once. Make the replacement. We're going to do this. Boom. Even that's more efficient. You're not sitting there going and having to cannibalize some sort of other, kid out there. You're ready to go.
Yeah, no, your enterprise asset management system has already gotten the message. He's already filled out the work order. He's already checked that you have the tools. The guy has the necessary competence. The spare part is in the warehouse on this shelf.
Love it.
You're all ready to go. And so there's a terrible statistic about maintenance. Like 80% of maintenance is either done wrong or at the wrong time. But if you can have the guy equipped with this kind of knowledge and prepare and go out and do the right maintenance at the right time, and it's done quickly, efficiently, boom, that's going to save you a tremendous amount of money, and we need that right now. Right now.
The future is now, and by the way, all of that is makes a safer work environment too. Big time. I mean,
we're not going to surprise. We're going to protect the environment, but our priority is our people. And so if I have people out there, I don't want them surprised by some integrity issue that we didn't spot ahead of time.
We're going to have to wrap this interview up. That is David Hartell. That's Hartell. He's with the company. Now, I'm not going to say New Age. I'm going to have to say the whole thing because your domain name is like that. He's with New African Global Energy. He knows what he's talking about. Digital Twin was on the docket for conversation here on the Industrial Talk podcast. David, one last question. Are you active out there on LinkedIn?
I am. Yeah, I blog every week, and I just posted blog 48 this morning. I'm having a lot of fun at it, sharing some of these stories because there's so many great people with so many great technologies and tools. There's a lot of experts out there that I like pointing people to.
Is that the IIOP.info for your blogs? Is that what is that?
That's my personal website where I'm also putting links to this, but they all start out originally posted in LinkedIn, so people can go profile there.
I like it a lot. Reach out to David Hartell. And then, of course, you're saying, hey, there might be a lot of David Hartells. Maybe. I don't know. But type in New African Global Energy. You'll find them with no issues. Not one bit on LinkedIn. David, thank you very much for joining the podcast. Really enjoyed the conversation. Like it a lot.
Thanks a lot, Scott. It's been fun.
You listeners, hang tight. We're going to wrap it up on the other side, so stay tuned.
You're listening to the Industrial Talk Podcast Network.
All right. Thank you very much for joining the Industrial Talk podcast. Absolute honor that you joined. It is always great. It's a wonderful conversation with David Hartell. What an honor to be able to have that conference. It is so amazing what we can do virtually and to be able to interact with great people like David and others. It is such an interesting time. I mean, I'm just excited about the whole thing. Go out. You got to visit. He's got the website is newafricanglobalenergy.com. The personal LinkedIn is, of course, William David Hartell. Type in the company New African Global Energy. Boom. You're good to go. Companies, there's a company LinkedIn. You got it all out there. It will all be on his landing page for this particular podcast. Remember, everything, the decisions that you're making going forward will have to be based off and pinged off of reducing risk, saving money, making money, everything. And that is through your collaborative effort. That is through innovation. That is through education. And that is with a sense of speed and urgency. And that you're going to have to make mistakes. No doubt about it. So everything has to look at that. Okay, we're doing one last thing. Heroes of Manufacturing. Go out to heroesofmanufacturing.com. Let's celebrate those people. Thank you very much for joining the Industrial Talk podcast. Be bold, be brave, dare greatly, change the world. That's what you're doing. Thank you and have a great day.